Our next conic shape is going to be the ellipse. So we see right here the equation for the ellipse. It is a little bit more complicated than the circle one. The circle, we see some similarities. The circle had the h minus k, or x minus h quantity squared, and the y minus k quantity squared. So that should be familiar from your circle. The difference is on the bottom we have an r of x and an r of y. If you remember what r stands for, it's the radius. So that's the radius for the x and the radius for the y, instead of being set equal to r squared. So in a circle, it was set equal to what the radius was. We have different radii, so our equation set equal to 1, not the radii. So now we have the center. It's the same as the circle. X minus h. H is at the center for the x. K is for the y. The r of x is the radius in the x direction. And we know that the x is going to move left and right. So if it's positive, it's going right. If it's negative, it's going left. So the radius, the r of y is the radius in the y direction. And we know that y is going to move up and down. If it's positive, it's going up. If it's negative, it's going down. Because we have two different radii, it's not the same around the whole shape. It's going to create a major axis and a minor axis. The major axis is the axis with whichever radius is larger. And the minor is the smaller of the two radii. Now what we're going to do with all this information. So we're going to pull the information that we need from the equation and then we'll graph. First, starting with the center, I see x minus 2. This is going to tell me that the x is at a positive 2. Y plus 3 tells me that the y coordinate of the center is at a negative 3. See how my variable x is here? Well, on the bottom, that's telling me my r of x. So my radius in the x direction is 6. Since my y is here, the number underneath y, that's my r of y, the number going in the y direction. So we have a major and we have a minor axis. The major axis is whichever radius is larger. When we look here, we have r of x. This is larger, so this is going to be our major axis. Why that matters is because our foci, which we haven't talked about yet, will go on that major axis. Now we want to find this c and foci value. The c is the distance from the center of your ellipse to the foci, and the c value is going to be the major the major axis minus the minor. So the larger of your two minus the smaller of your two. So in this case, it's 6 squared minus 4 squared, giving us 36 minus 16, which is 20. That's equal to c squared, so we square root. You are only going to round to the nearest tenth. So if I take the square root of 20, I'm going to get about 4.5. So the c value, c is about 4.5. Before we do our foci, let's go ahead and just start getting graphing here. We have the center of our ellipse at 2, negative 3. The r of x is 6. So the radius in the x direction is going to be 6. So I'm going to count 1, 2, 3, 4, 5, 6 right. I'm going to count 1, 2, 3, 4, 5, 6 left. The r of y, the radius in the y direction, is going to be 4. So from the center, I go up 1, 2, 3, 4. From the center, I go down 1, 2, 3, 4. that's going to give us our shape. And it's not a circle because a circle is the same radius all around. An ellipse is that stretched out circle, kind of like a football shape. Because our r of x was larger, clean that up a little bit, it was making our ellipse be more stretched out in the x direction. Now this is where our c value is going to come in, our foci. Our foci are going on the major axis, so it's going to go in the direction where we went longer, which in this case is the x direction. To get those foci, I'm going 4.5 from the center in the x direction. So I go from the center and I go 1, 2, 3, 4.5. I go left, 1, 2, 3, 4.5. Those are going to be my two foci points. For ellipses, the foci will always be inside of your circle. So if I look here, I'm at 6.5, -3, and the other foci is at a -2.5, -3. So counting to the right 4.5, I have the first foci point. Counting to the left, I have my second foci point. It doesn't matter which one you say is foci 1 and which one you say is foci 2. But don't forget that the foci will always be inside of your ellipse. If you plot your points and it's outside, you made a mistake. All right, our last one, write the equation of the given ellipse in graphing form. So when we go all the way back up, what do we need to write our equation? It's set equal to 1, so I don't need any information there. I need my center of the circle for the h and the k. I need the r of x, and I need the r of y. So I only need 3 pieces of information from this graph. I need the center, I need the r of x, and I need the r of y. Those are the 3 things I need. So I look at my diagram. Here's my center of the circle, or ellipse. The center is at a -4, +2. The r of x is the distance in the x direction, so 1, 2, 3. You can count left or right because they're both 3. And then the distance going up and down, 1, 2, 3, 4, 5, 6. I could have counted down as well, 1, 2, 3, 4, 5, 6. So the r of y is 6. Using this information, we think about the general form, again, as x minus h over r of x quantity squared plus y minus k over r of y quantity squared equals 1. Now here's the center, so it's -4 for the x, which is going to make that a +4 because it's always the opposite. The r of x, the radius in the x direction is 3. Y minus k, your k is 2 because that's the y value of your center, all over r of y, which is 6 squared equals 1. Make sure that you don't forget to say equals 1. Without the equal sign, you don't have an equation. It has to equal 1 in order for it to represent an ellipse. All right, that is our ellipse shape, and we are done for today.